All right, today, welcome back to the PyCSE channel. Today I want to talk about reading data files into Colab. It's one of the trickier aspects of doing things with Colab, in my opinion, in part because Colab is a cloud environment that doesn't know about the files on your desktop. It doesn't really know about files in your Google Drive without doing some work to connect them. And it's not always obvious how to do that. And today I want to show you one way to think about doing it. So we'll start by looking at this NIST data site that has some data archives, and I want to focus on the linear regression module here. So if we click on this, there's a couple of data sets in here, and we'll start with Norris. It's the top one, and this is data that is used for testing linear regression algorithms. And the thing that's interesting is that there is a data file here. I'll click on it in a moment, well, maybe now. And this is a regular text-based file that has data down here at the bottom that we might want to be able to read in and plot and maybe do some linear regression on. So the question now is, what's the best way to get this data file, this .dat file, into Google Colab? Now, there is a way you could download this file to your desktop and then drag it over to your Google Drive and then mount your Google Drive and then get to it. But I want to show you a different way to think about it. So first, let's copy this URL because the URL points to this text data that we're going to use. All right, and then we'll go over to Google Colab here, and I'm going to create a new Colab. And it's now spinning up. And let's name this one Norris, maybe. Norris data. So the critical thing to remember about Google Colab is that this has launched a kernel that's doing calculations somewhere in the world, but that is a computer somewhere far away that has no knowledge of anything on your desktop and at the moment nothing in your Google Drive. And this button over here on the left, if you click down here on the file, then this is how you can connect it to the Google Drive, but we're not going to do that today. All right, so the first thing I want to show you is that we can sometimes use Pandas to read in a file automatically. So let's import Pandas, and spoiler alert, this is not going to work, but we're going to try it anyway, because eventually we're going to make it work. All right, so if I just put this in and run this, now it's going to start, and what it says is error tokenizing the data. There's a C error, expected 1 fields in line 10 and saw 3. Now let's go back and look at what the data we're trying to read in and try to get some understanding of why this was a bad idea in the first place. So this was a bad idea because all of this kind of stuff at the front is considered header data, and it's very unstructured compared to this data where we have 2 columns of numbers. So if the whole file looked like this, it would be easy to read in like we just tried, but it's not like that. And so we have to look at this and skip a bunch of these lines in the process. Now, how do we get to what we should skip? To do that, we need to do some analysis on this. And if this was an editor, it might tell me what line I was in here. But we'll take take this as an opportunity to try something new. All right, so let's go here and add a new cell. And let's go ahead and download this file into the Colab. So we'll do that with the URL lib request library. And then we just type URL lib.request.url retrieve, and now we put in that URL, and we're going to give it a name that we want to save it in. All right, and before I run that, if we do !ls, that will show me what kind of files are in here, and you can see it over on the left here. This is some sample data that doesn't have what we want in it. But otherwise, we're in a directory that has nothing in it. And when I run this, now you see it downloaded this. And if I run this ls again, you see norris.dat. And now over here, a few seconds later, you see that we got the norris.dat file. And let's just see if we can open it. No, it looks like we can download it. And so we still have to do some inspection of the contents of it. All right, so let's see. If you're familiar with Unix commands, you can still run those like this. So here we can just see the contents of the file, and that's not super helpful since we still don't know what column or what row number these start in. So let's do this in a Python way. So what I want to do is read the contents of that file, and then we'll print each line with the line number. So for I, comma, line in enumerate, open, norris.dat, and then we will just print I, comma, line. So enumerate is a fancy way of taking each line from norris.dat and telling you what the corresponding index I of that line is. And so if we run that, we can see a bunch of things. First, we start out at 0, and then as we go down the way, we can see that the data starts on line 60. So we would want to skip 60 lines before we get to the data. And as we get to the end, you can see there's one blank line, and that's something we probably need to account for when we do the file reading. Okay, so let's go back to pandas.read and check out the documentation. This read CSV line is a very sophisticated function. It takes all of these different arguments to do different things. The thing that is most relevant for us is probably where it has something about skip rows. Let's see, we have path, delimiter, header, names, index, use column, squeeze. Here's skip rows. All right, so here are two things that we can set to skip a certain number of rows before we start reading, and also we'll see what skip footer does. So let's go down here and see where is the skip rows. All right, so skip rows is the line numbers to skip, 0 indexed, or number of lines to skip at the start of the file. All right, so let's go back up to the top, and I'll just copy this line back down to here. And now we're going to say skip rows equals 60. And that gives us something that's almost right, but we probably need to put in some delimiter because it's reading the two numbers together. You go back here, it's not obvious. These are white space delimited. So let's go back over here. It's CSV because it normally assumes commas, but we need to look down here at this delimiter and figure out what the best thing to do is. So it looks like we would want to do something like this. Maybe we'll just try /t for tab. And that's not enough. It's probably also spaces. Maybe we'll try just a space. That's not it either. Okay, here is for spaces. So this is a regular expression, /s is a space and plus means more than one. And now we have two columns, and the only thing is that we see is the top one is getting used in as the column names. And so probably we need to look at index column. And let's go back here and see what these things should be, Y and then X. Either that or these should be names. Okay, so now we have this data frame in Pandas form that gives us the Y data and the X data. And let's go ahead and save that in a variable now, Pandas data frame. And now we can make a plot. So we could say import matplotlib as like that, and then plot.plot. We could say df x. So it's going to take the x column and the y column. And that is the line that that we expect. Maybe we'll put blue circles so you can see where the points are. And this is really the big benefit of using something like the Pandas data frame to read in this file. But now that we know this information, it's not necessary. We could also use numpy.loadText. So let's work out that. Import numpy as np. And then let's take a look at the doc string for np.loadText. So this takes a file name, and we can also put in a delimiter, and there's also a skip rows, and then there's a max rows. So we'll see if we need to come up, do that one. So np.loadText norris.dat. Again, if this was a regular well-shaped file, we could just get away with this, but it's not. And so for the same thing that we did above, we're going to say skip rows equals 60. And we should probably put in the delimiter, same delimiter as before, as spaces. And let's see, that could not convert to float. All right, so this one is a little trickier maybe. Let's see, what does it say about delimiter? The default is white space. All right, let's get rid of that then. Okay, so now we get the two arrays, and these are in columns. So let's look at one more detail that says unpack. Let's say unpack equals true. And what that lets me do is save these directly into two variables named x and y. So the first column is y and the second column is x. And now then we can make a plot of those two things. And it should look like the same line as before. We'll make red circles this time. Okay, so that's basically the main idea of this video today, is that it's a little bit tricky to get data files onto Colab. One way you could do it is to mount your Google Drive and put it there. Another way you could do it is what I showed you today, which is that we download the file into Colab. And I should point out, if you close this notebook and then come back and reopen it, this file is going to be gone. So you'll have to download this file every single time you want to use the notebook. That's because the disk space that we have here, down here, some 60 gigabytes, is not our disk space to keep forever. We're kind of borrowing it for a short time here. So what I did was just download it into this path here. And that path is, if you go up, these are the full, all the things that are available in this virtual machine that we're running. And we don't normally need to get into any of those. But in the content here is where we downloaded this file. Then this file, if you recall here, it has all this header information, and it's unstructured header information. So we don't want to include that in what we're reading just to get this data down here. And so we figured out which part was the header by printing every line with a number, so that we could see that we wanted to skip 60 of these lines. And then we could read the rest of them, and in this case the last line didn't cause us any problems. So to get that to happen with Pandas, we had to specify the space delimiter and give it some column names. We used the URL directly that we read from, so that was kind of convenient. And then with np.loadText, we used norris.dat, and this we could have also used that file name. So now that we have it, you could also just read the local file name like this, and you get the same answer. Now it's a little bit different when you read it into a data frame than when you read it into the NumPy array. So with this data frame, you can access the columns by these names, and what we did down here was unpack these directly into variables. And which one you do really depends on your application and why you want variables versus column names. From the data frame, you can probably do df.plot, and I'm kind of guessing here, something like this. Maybe we do x versus y. So we can use the names of the columns to indicate what's getting plotted, which is pretty nice compared to down here where we have to use these and create these variables. So that's it for this kind of short summary on how to download a file from a URL into a temporary space on your Google Colab directory, and then read it with Pandas or via NumPy. So I hope that is helpful to you sometime, and till next time, have fun playing around with it.